A critical production bug just hit. Your server is bleeding users, the logs are screaming, and you're frantically digging through thousands of lines of legacy code to find a missing null check or a race condition. In the past, we called this debugging, and it took hours of manual tracing. But in 2026, while you're still reading stack traces, your competitor has already identified the root cause using an autonomous AI agent, generated a regression test, and deployed the fix in under 120 seconds. This isn't just a slight improvement in speed, it's a fundamental shift in survival. If your workflow still relies on manual syntax verification and local environment setup, you are becoming a bottleneck to your own career. The industry has moved from writing code to orchestrating outcomes. By the end of this lecture, you'll see why the way you've been taught to code is actually your biggest weakness in this new era. Let's talk about vibe coding. It sounds like a joke, but it represents the most significant shift in engineering since the invention of the compiler. In the traditional paradigm, we think in logic gates and syntax. If this variable is null, then throw an error. In vibe coding, you describe the intent and the feeling of the outcome. You tell the system, I need a secure, scalable authentication flow that handles session hijacking. You aren't writing the code, you're providing the direction. The AI models like Claude 3.7 or GPT-5 handle the boilerplate, the syntax, and the unit tests. But here's the trap. You don't know how to vibe with the model correctly. It will hallucinate a disaster that looks perfect on the surface, but fails under heavy load. Does this mean we don't need to understand code anymore? The answer might actually scare you, and I'll show you why in the next slide. Imagine building a full-stack dashboard with real-time analytics, user roles, and a Postgres backend in the time it takes to drink a cup of coffee. We're talking under 15 minutes. In 2026, this isn't a fantasy. It's the professional standard for vibe coding. By orchestrating Cursor for the UI, Claude Code for the CLI-based logic, MCP to connect your local environment to live data, you bypass the blank page syndrome entirely. You start with a functional skeleton and spend 90% of your energy on the business logic that actually generates revenue, rather than fighting with Webpack configs. I've seen teams spend 6 months building what an individual can now prompt into existence in an afternoon. This is the promise of the 2026 workflow, but only for those who know how to avoid the syntax trap. This speed is incredible, but it creates a massive efficiency gap that is currently dividing the tech industry in two. The timeline of software delivery has collapsed. We used to measure projects in quarters and sprints. Now we measure them in prompts and refines. In the field, I see developers clinging to manual boilerplate creation like it's a badge of honor. It's not. It's a liability. Every minute you spend manually writing a C-Root API or setting up a CSS grid is a minute your competitor spends on market research or UX optimization. By 2026, the cost of human-written code has become so high that it's only reserved for the most sensitive core architectural kernels. For everything else, manual coding is essentially technical debt from day one because it's slower to maintain and harder to refactor. You need to move from the implementation layer up to the orchestration layer if you want to stay relevant. If we aren't writing the code, then what exactly is our job? Let's look at the evolution of the developer role. You are no longer a writer. You are a conductor. Think of a symphony. The conductor doesn't play every instrument, but they know exactly how the violin should sound and when the drums need to enter. As a conductor of AI models, your skill isn't in memorizing Python libraries. It's in understanding system design, context injection, and validation. You need to know how to feed the right context into the model context protocol, so Claude knows exactly what your database schema looks like without you having to explain it. You're managing a team of infinitely fast junior developers, and your value lies in your ability to review, verify, and steer their output toward a cohesive goal. If you can't articulate the architecture, the AI will build a house without a foundation. But a conductor is useless without their instruments, so let's look at the 2026 tool stack that makes this possible. To execute this workflow, you need the holy trinity of 2026 development. First, there's Cursor, the AI-native IDE that understands your entire codebase through local indexing. Then there's Claude Code, which acts as your terminal-based agent, executing complex CLI tasks and refactors across multiple files autonomously. Finally, there's the Model Context Protocol, or MCP. This is the glue. MCP allows these AI models to securely reach out and touch your local files, your databases, and even your cloud services to gather context in real time. When these three tools work in harmony, you aren't just coding, you're operating a high-speed production engine. Mastering the interaction between these three is the difference between a vibe coder who creates bugs and a senior engineer who ships products. Now that we know what's at stake, it's time to build the engine itself. Let's move to Chapter 2 and architect the God-tier workflow. In the field, I see so many developers treating Cursor like just another VS Code skin with a chat window. That is a rookie mistake. In our 2026 workflow, Cursor acts as the spatial brain of your development environment. It doesn't just look at the file you have open, it indexes your entire codebase to understand the relationship between your React components and your Python backend. When you use the Composer feature, you aren't just asking for a snippet. You are directing an architect to rearrange the furniture in a room it already knows by heart. The real power comes from the indexing phase where the AI maps out your project structure, but even a perfect map is useless if the architect can't actually move the bricks. This is where most people get stuck, thinking the IDE is the end-all be-all of the process. But wait, if Cursor is the architect, who is the heavy lifter executing the commands in the basement? If Cursor is your eyes and hands, Claude Code is your autonomous tactical agent. Unlike a standard chatbot, Claude Code lives in your terminal and operates with a think-before type philosophy. It doesn't just guess what's wrong. It runs terminal commands, inspects logs, and searches your file system to find the root cause of a bug. When you tell it to fix the auth issue, it doesn't just output a code block for you to copy-paste. It navigates your directories, reads the config, and executes the fix itself. This shifts your role from a writer to a reviewer. You're no longer the one fighting with syntax errors. You're the senior engineer overseeing a junior who is incredibly fast but needs clear direction. But even the smartest agent is limited by what it can see and touch within the sandbox of your terminal. How do we break those walls down? The answer lies in a protocol that's currently changing everything. This is where the God tier part of the workflow starts, the Model Context Protocol, or MCP. Think of MCP as the universal USB-C port for AI. Before MCP, if you wanted Claude to see your database schema or your Jira tickets, you had to manually export data or build custom integrations. Now, MCP creates a standardized bridge. It allows any LLM, whether it's inside Cursor or Claude Code, to securely plug into external tools and data sources. It's a client-server architecture where the AI is the client and your local environment or an API is the server. When you ask the AI about a database error, it uses the MCP bridge to actually query the database and see the real rows and columns. This turns the AI from a language model into an integrated system component. But how does the data actually flow through this bridge without making a mess? Let's trace the journey of a single prompt. Let's look at the lifecycle of a request in this workflow. Imagine you say, fix the UI and update the task status in GitHub. First, Cursor spatial indexing identifies which CSS and React files are relevant. Simultaneously, Claude Code identifies that it needs to interact with the GitHub API. It sends a command through the MCP GitHub server. The MCP server translates this into a real API call, gets the result, and feeds it back. This isn't just vibe coding, it's precision-engineered automation. The vibe is just the interface. The engineering is the protocol-driven data flow. You are orchestrating a multi-agent system where every tool knows its place. But even with this perfect flow, you need to know which specific limbs to attach to your AI brain, which MCP servers are actually worth your time in a real production environment. Let's break down the essential catalog you need to install right now. To build a truly autonomous workflow, you need the right MCP servers. Think of these as superpowers you grant to Claude and Cursor. The file system server is the most basic. It lets the AI read and write with safety guards. But the real game changers are the GitHub server for managing issues and PRs, the Postgres server for direct database inspection, and the Brave Search server which gives your AI live internet access without hallucinating. I've seen teams waste weeks building custom scripts for things these servers do out of the box. By plugging these in, you're not just coding, you're managing an entire ecosystem from a single prompt window. However, there's a massive elephant in the room when you give an AI this much power. If it can read your files and query your DB, what stops it from deleting everything? We need to talk about the agentic risk and how to mitigate it. In the field, agentic risk isn't just a buzzword, it's a real threat to your production data. When you connect an AI to your database via MCP, you are essentially giving it a loaded gun. The key is to follow the principle of least privilege. Never, and I mean never, connect your AI to a production database with write access. Use read-only credentials for MCP servers during development. Also, be mindful of your API keys. MCP configuration files are often stored in plain text locally. If you're using Cursor, make sure your dark cursor rules explicitly forbid the AI from touching sensitive end files. Security in the vibe coding era isn't about building walls. It's about setting boundaries for your digital agents. But even with these risks, the setup process has become so simple that most people skip the security check. Is it really zero configuration like they say, or is there a catch? Setting up MCP is designed to be frictionless, but frictionless often leads to messy. Most servers can be launched using npx, meaning you don't even have to install them permanently. You just reference the package and the MCP host handles the rest. For example, to give Claude access to your local files, you just add a single line to your config. The goal is to reach zero configuration where the tools discover each other. However, the senior developer's advice here is, explicit is better than implicit. Even if it's easy to add 10 servers, only add what you need for the current task. Overloading the context with too many tools makes the AI slower and more prone to errors. We want a lean, mean coding machine. Now that we have the pieces, let's see how they stack up into a final architecture. What does the God tier stack actually look like when it's fully assembled? Behold the full architecture of a modern AI-driven workflow. At the top, you have the intelligence layer, the LMMs like Claude 3.5 or 3.7. Below that is the interface layer where Cursor and Claude Code reside. Then, the protocol layer, our MCP bridge, connects everything to the resource layer, which includes your local files, your databases, and external APIs. This isn't just a stack, it's a nervous system. The AI thinks at the top, and the MCP servers act as the nerves that trigger muscles in the real world. When you master this, you aren't just a vibe coder anymore. You are a systems architect who uses AI as a primary component. You've moved from writing lines of code to directing an entire infrastructure. Now that we have the blueprint, it's time to stop talking and start building. In the next chapter, we are going from zero to a live launch using this exact workflow. Are you ready to see the machine in action? When you start vibe coding, the biggest mistake is jumping in without rules. Your AI agent is like a brilliant but erratic junior dev. Without a handbook, it'll mix snake case with camel case and use libraries that were deprecated 3 years ago. This is where cursor rules comes in. Think of it as the constitution for your project. You aren't just giving a prompt, you are defining the architectural boundaries. In this file, we specify that we only use Next.js app router, we strictly follow TypeScript strict mode, and we prefer Shat and UI components. By setting this up first, you ensure that every line of code the AI generates aligns with your vision from the very first second. If you skip this, you'll spend half your time fixing linting errors instead of building features. But even with rules, the AI is still trapped in a sandbox. How do we let it touch the real world? Let's talk about the CLI. Now, let's look at the powerhouse, Claude Code CLI. Most people are used to the chat window in the browser, but for a 2026 level workflow, that's amateur hour, we need an agent that lives in our terminal and has the authority to run commands. Installing the Claude Code CLI is your first step into actual agentic development. When you authenticate via your terminal, you're giving Claude the eyes to see your local environment and the hands to execute and npm install or git commit on your behalf. This isn't just about typing, it's about shifting the manual labor of environment setup to the machine. You give the command and Claude handles the plumbing. However, a CLI is only as good as the data it can access. Having a CLI is great, but what if your AI needs to read your local database or your Google Calendar? That's where the protocol comes in. This is the secret sauce of the modern stack, the Model Context Protocol, or MCP. In the old days, AI was a black box that knew nothing about your local files unless you pasted them in. With MCP, we create a bridge. By running a local MCP server often inside a Docker container for security, you allow Cursor or Claude to query your local environment like an API. Imagine your AI agent being able to run a SQL query against your local Postgres database to understand the schema before writing a data fetcher. That's what MCP linkage provides. You add the MCP endpoint in your Cursor settings, and suddenly the AI has contextual awareness. It no longer guesses, it knows. The setup looks perfect on paper, but in the real world, connections fail and permissions break. Here is how you verify it actually works. Before we write a single line of code, we must validate. I've seen too many developers waste hours wondering why their AI is hallucinating, only to find out the agent didn't have right permissions to the folder. This 5-point checklist is your pre-flight routine. First, ensure the MCP tools are visible in the Cursor Plus menu. Second, check that Cursor Rules is actually indexed. You can see this in the logs. Third, verify the Claude CLI has full disk access if you're on macOS. Fourth, run a simple test. Claude, tell me about the files in this folder. If it can't list them, your bridge is broken. Finally, check your API credits. There's nothing worse than an agent stopping mid-refactor because you hit a limit. Now that the engine is purring, it's time to put your foot on the gas with the first prompt, but most people drive straight into a wall. Welcome to the world of vibe coding. The biggest hurdle for traditional developers is unlearning micromanagement. In the old world, you'd prompt, write a function that takes an email string and validates it using regex. That's boring and slow. In the vibe coding era, we prompt for intent. You say, I need a secure, modern user authentication system with magic links and social login. You describe the vibe and the outcome, not the logic. The difference is architectural. By prompting for the feature, you allow the AI to choose the best libraries, structure the folders, and handle the edge cases that you might forget. You become the creative director, not the typist. The intent is clear, but how does a CLI tool take a vibe and turn it into a folder structure? Let's watch Claude Code think. When you hit enter on a vibe prompt, Claude Code doesn't just start typing. It performs intent extraction. It goes through a chain of thought process. Okay, the user wants an auth system. I need a database schema, a middleware for session handling, and 3 UI routes. It builds a mental model of the entire dependency graph before a single file is created. This is the zero to plan phase. It identifies which MCP tools it needs. Maybe it needs to check your existing package JSON to see if Lucia auth or auth.js is already there. It reconciles your vague vibe with the strict reality of your tech stack. If you watch the CLI logs during this phase, you'll see it thinking about file paths. A plan is just words. Let's see the code actually manifest in real time. Watch this. With one command, Claude Code starts scaffolding. It's not just creating empty folders. It's generating production-ready boilerplates. It creates the layout TS for the shared UI, the page.tx for the root, and the API handlers. Because it's 2026, it's using the latest patterns, server actions, React server components, and optimized image loading. It's writing the CSS in Tailwind, following the Emerald theme you mentioned in your rules. It even handles the boring stuff like exports and imports that usually cause reference errors. In about 30 seconds, you have what used to take a senior dev half a day to set up. The scaffold is up, but it's never perfect. This is where most beginners get stuck editing the AI's work manually. Don't do that. The secret to 10x productivity is iterative feedback via the cursor composer. Once the scaffold is there, you don't touch the keyboard to type code. You use CND+I and talk to it. The login button looks a bit small, make it more prominent, and add a loading spinner. The AI then refactors the specific component without breaking the rest of the app. This iterative loop is where the vibe becomes a product. You are sculpting the software with words. If it makes a mistake, you don't delete the file, you say fix the hydration error in the navbar. This feedback loop is the core of the 2026 workflow. We have the skeleton and the skin, but a production-ready app needs a heart and a brain in the next chapter. We make this real by connecting logic and data. In the field, the biggest hurdle for beginners isn't just writing syntax, it's connecting to the outside world. This is where Claude Code and MCP shine. Instead of you manually reading API docs and writing fetch logic, you simply tell the agent to fetch the latest market data using the stock TP tool. The agent doesn't just write the code, explores the available tools, understands the schema, and implements a robust integration. In a production environment, this eliminates those typo in the endpoint bugs that haunt junior devs. We aren't just copy-pasting anymore, we are orchestrating agents to perform complex I/O tasks autonomously. But getting the data is only the first step. How do we make this raw data look like a professional product without spending hours on CSS? Let's look at the UI workflow next. Many developers feel a sense of dread when it's time for styling. With Vibe coding, we leverage Tailwind CSS through Cursor's Composer or Claude's artifacts. You don't need to be a designer. You can simply provide a screenshot of a dashboard you like or describe the Vibe as dark mode minimalist with neon accents. The agent applies utility classes instantly. However, the senior approach is to maintain consistency. Instead of letting the AI go wild with random colors, we instruct it to follow the existing Tailwind config and use the primary branding colors. This ensures the UI looks cohesive rather than a patchwork of random styles. But wait, looks can be deceiving. How do we know if the logic behind this pretty interface actually works? Let's talk about verification. Trust, but verify. That's the mantra of an experienced engineer. When an AI generates a complex business logic function, you shouldn't just assume it handles edge cases like null values or network timeouts. The workflow here is simple. Highlight the code and prompt, write comprehensive unit tests for this using Vitest. The AI will generate tests for the happy path and, more importantly, the failure paths. If a test fails, you don't fix the code yourself. You feed the failure log back to the agent. This creates a feedback loop where the AI corrects its own mistakes until the green lights appear. This is the difference between a prototype and a production-ready app. But what happens when the build itself breaks in the terminal? That's where agentic debugging comes in. The most powerful feature of Claude Code is its ability to live in your terminal. Traditional coding involves a cycle of write code, run command, see error, search Stack Overflow, repeat. With agentic debugging, the agent sees the error the moment it happens. It can read the stack trace, check your file system, and fix the underlying issue without you ever leaving the terminal prompt. It's like having a senior engineer sitting next to you who never gets tired. We call this autonomous loop resolution. You just say fix the build errors and watch the agent navigate the files. We have a working app now, but it's only on our local machine. How do we ship it to the world without clicking a single button? I'll show you how to automate the entire deployment in the next section. Shipping code used to mean manually dragging folders into an FTP client or wrestling with complex Git commands. In 2026, we use the GitHub MCP. You simply instruct your agent, initialize a new repository named My Vibe app, commit all current changes, and push it to GitHub. The agent handles the SH keys, the remote origin setup, and the initial push. It can even create a README command and license file autonomously based on your project structure. This isn't just about speed, it's about reducing the friction between an idea and a live product. When the setup is automated, you spend more time on the what and less on the how. But once the code is on GitHub, where does it actually live for the public? The answer lies in the cloud integration. Now we move to the final stage, production deployment. Using the Vercel CLI combined with Claude Code, we can trigger a live deployment directly from our conversation. You tell the agent, deploy this to production, and it handles the environment variables, build settings, and domain mapping. If the build fails on the server due to a missing dependency, the agent reads the deployment logs, installs the missing package locally, and repushes. This self-healing deployment is a game changer for solo founders. You no longer need a dedicated DevOps person to manage your pipeline. However, we must be careful. Automated deployments can be expensive if you trigger them too often. Is this method actually sustainable for your wallet? Let's take a look at a real-world cost analysis. Let's look at what we've built. From a blank folder to a fully functioning, styled, and deployed application in under an hour, we have a real-time data integration, a responsive UI, and a verified backend, all orchestrated by agents. This is the production-ready standard. You can share this URL with potential users or investors immediately, but don't let the speed fool you into thinking the work is done. As a senior developer, I can tell you that the real challenges start after the first deployment. Monitoring, scaling, and handling real user feedback are the next hurdles. Before we move on, we need to address the elephant in the room, the cost of this Vibe coding magic compared to traditional development. It's time for some hard numbers. Is Vibe coding actually cheaper? Let's compare. A traditional junior developer might take 20 hours to build this MVP at a cost of thousands. With Claude Code and Cursor, you might spend 20 to 50 in API tokens in a few hours of your time. The ROI is astronomical. However, there is a catch. Token costs scale with the size of your codebase. If you aren't careful with your context management, you can burn through your budget quickly. In the field, we optimize this by using smaller, specialized agents for specific tasks rather than one giant context. This efficiency is what allows small teams to compete with large corporations. Now, this all sounds like a dream, but what happens when the AI hallucinating? In the next chapter, we look at the battle stories, the moments when AI goes rogue and how to survive the chaos. In the field, we often see developers getting too comfortable with long context windows. Imagine you're building a multi-tenant SaaS using Cursor and Claude. You've established a strict database schema where every table must have a tenant ID for data isolation. After 3 hours vibe coding new features, you ask the AI to refactor the payment logic. Because the schema file was flushed out of the immediate active context, the AI hallucinates a simpler structure and rewrites your migration files, completely stripping the tenant ID columns. If you just hit accept all without checking, you've just created a massive data leak vulnerability where users can see each other's data. This isn't a theoretical risk. It happens the moment the context window drifts. But how do we spot these subtle shifts before they ruin the architecture? The answer lies in how we manage the human-in-the-loop process. Question, is the AI truly understanding your architecture, or just guessing based on the last 5 minutes of conversation? Many beginners think the goal of AI coding is to never touch the keyboard, but that's the vibe coding trap. When you see the AI agent performing a looping behavior trying to fix a CS alignment issue by rewriting the entire layout component 3 times, you must intervene. This is the stop and sync moment. In a real-world scenario, I've seen AI agents try to resolve a simple API timeout by adding 3 different redundant retray libraries because it didn't realize the first one failed due to a local network issue. As a senior engineer, you must treat the AI as a junior developer with infinite speed but zero common sense. You have to review every diff as if your production environment depends on it, because it does. But even if your logic is sound, there is a much more dangerous trap waiting in your environment variables. Payoff up next, we'll look at the nightmare of the automated security breach and how one wrong enter key can leak your life's work. The most terrifying rogue behavior isn't a bug, it's an overeager AI agent trying to be helpful. In 2026, tools like Claude Code or MCP-enabled agents have terminal access. You might say, get this project ready for GitHub, and the agent, wanting to be thorough, runs a git add and git commit. If your git ignore wasn't perfectly configured the second you started, your end file containing Stripe secret keys or AWS credentials is now live on a public repository. Within 60 seconds, bot scrapers will have cloned those keys and started spinning up 100 GPU instances on your dime. This is the secret leak trap, and it's the #1 reason beginners go bankrupt in the AI era. You cannot rely on the AI to remember security best practices for you. Teaser. So, how do we build a safety cage around these powerful tools? Next, I'll show you the non-negotiable configuration every cautious engineer needs. Mitigating these risks requires a security-first mindset before you even type your first prompt. First, your gitignore must be a fortress, include denv, pem, and any local MCP config files that might contain tokens. Second, leverage MCP server permission settings. When you connect a file system MCP, never give it write access to your entire root directory if it only needs to touch the S3 folder. Use cursor rules to explicitly instruct the AI, never modify files in the config directory without explicit permission. In the field, we call this the principle of least privilege. By setting these boundaries, you transform the AI from a dangerous rogue agent into a disciplined assistant. This covers the battle stories of what can go wrong, but how do we stay ahead in this rapidly evolving landscape? Bridge. In our final chapter, the conclusion, the 2026 roadmap, we will map out your specific growth strategy to stay relevant in the age of vibe coding. In the world of 2026, the traditional hierarchy of coding skills has been completely inverted. Syntax is now a commodity. Claude Code and Cursor can write perfect Python or TypeScript loops faster than you can think. The real bottleneck isn't how to write code, but how to design systems. If you spend your time memorizing API signatures, you're losing the game. Professional engineers now focus on system design and MCP orchestration. You need to understand how data flows between your front end and your agentic tools. Think of yourself as an architect, not a bricklayer. The difference between a hobbyist vibe coder and a pro is the ability to define clear interfaces and data schemas that AI can reliably navigate without hallucinating. This architectural thinking is what prevents the spaghetti prompt disaster we discussed earlier. You must master the art of breaking down a massive monolith into digestible, MCP-ready modules. But wait, knowing where to go is only half the battle. How do you actually transform your current messy projects into this new reality? Let's look at the immediate transition steps. To wrap things up, your final action item is to move beyond simple chat-based coding and into agentic workspaces. Stop just opening a folder in Cursor and hoping for the best. Instead, begin building your own custom MCP servers that expose your unique business logic, database schemas, and even production logs to Claude. This creates a feedback loop where the AI isn't just guessing, it's operating based on the real-time state of your system. In the field, we see the most successful developers are those who treat their development environment as a living, breathing ecosystem of agents. Convert your documentation into Markdown, standardize your project structure, and use Claude Code to automate your deployment pipelines. The vibe coding era is here, but it only works for those who build the right guardrails. This lecture was just the beginning of your journey into the 2026 workflow. The tools will continue to evolve at a breakneck pace, but your role as the strategic architect is more vital than ever. Now, take these tools MCP, Claude, and Cursor and go build something that was technically impossible for a single human just 12 months ago.